Hello, and good morning, afternoon, or evening to you. By now, before you attempt this problem, or any problem similar to this one, I'm assuming and hoping that you're already familiar with parent functions, more specifically linear, quadratic, and cubic functions. If you are, please feel free to skip ahead about a minute into the video. If not, I will quickly go over what's necessary to know. So when you have an odd function, such as this one, which is just f of x is equal to x, what's important to note about odd functions is that when they approach the x-axis, which is this one right over here, they will cross or go through where y is equal to 0. The same thing applies to a cubic function right over here, such as x to the third, or any one that looks like x to the third and has that particular shape. It will go through the x-axis at some given point. Whereas when you have a function with an even, what's the word I'm looking for here, exponent, you're going to have behavior that looks like a parabola in that it'll go towards the x-axis, whatever side it may be on, could be on this side as well, and it will touch or bounce at the x-axis but not actually go across. And so that's what you needed to know before attempting this problem. So when you're constructing the polynomial function from a given graph, when you're asked to do that, the first thing you need to do is start with your zeros, because they're already given to you, and that's honestly the easiest way to start. Although it's not written down here, know that this is the origin and that that is 0 and 0 right there. So 0, positive 1, and 2 are points at which the x-axis is touched or passed through. Next, what you need to do is figure out the behavior near each one of your zeros and determine the degree of the zeros. So in this case over here, at 0, it's not moved to the left or to the right, it's just at 0. So when you plug in 0 to a value of x, you don't have to change anything. All you'll have is x squared at that value, because the value right here looks like a parabola. So I guess you can't really see it right there. I'll move in closely for a second. I guess that doesn't really help because it looks like a reverse y. Just know that that's an x squared right there for that particular 0. In this case, though, we have x moved over right from the origin. And the way I'm going to write that down is x minus 1. That also looks like a parabola, so that needs to be squared. And if I plugged in a 1 for this value of x right here, which is what this is, that would equal the 0 at the y that we're looking for. Now this one over here is different from these two in that it crosses through, meaning that we have an odd exponent in this case. Whether it's 1, 3, it doesn't really matter. All that matters is that it crosses through over here, whereas these ones touch or / bounce off the x-axis. So this one, in this case, is going to be a linear function, or cubic, but in this case, I want to make this as easy as possible, so I'm going to go with a linear function, x minus 2. That's going to be my value of 0 at that point right there, my value of 0 at that point right there, and my value of 0 at that point 0 over there. So, once you have that, what you want to do is expand that out so that you're given a function. So, at this point it's just strictly computation. Let's see if I can actually get this to go down properly with one hand. In the first step, all you do is expand that first x minus 1 right there, because it has a multiplicity of 2. It's the same thing as x minus 1 times x minus 1. So when you multiply that by itself, you're left with x squared minus 2x plus 1. And of course the x squared from there, and the x minus 2 are both dragged down, because that's the only thing that's changed. The next, we'll multiply the x squared through, again for the purpose of simplifying. After you multiply x squared through, you'll have x to the fourth minus 2x to the third plus x squared. And again, that x minus 2 is brought down because nothing's really changed in that one until now. And what I'm going to do next is multiply this right here by this right here. And I am left with x to the fifth minus, let's see if I move this in closer if it's easier to see. Yeah, slightly. Hope that helps. Negative x to the fourth, negative 2x to the fourth, another negative 2x to the fourth, plus 4x to the third, plus x to the third minus 2x squared. When you combine like terms, you'll be left with negative 4x to the fourth, and when you combine these two terms over here, both with positive 3's as their powers, you'll be left with 5x to the third. And there is your function. But lastly, before we finish, let's make sure that the parent graph, or the parent function, is denoted, not denoted, but let's just make sure that, actually what I'm trying to say here is that this graph actually makes sense, and that this could be the graph of the function. So in this case, I have x to the fifth, and when you have x to the fifth, that will be very similar to x to the third, in that in the third quadrant it will head down and out, and in the first quadrant it will head up and out over here this way. So that right there tells you that your end behavior is going to look like an odd function. And well, there you have it.